Now we start with basic proportionality theorem, BPT. It is in geometry. We have to do second exercise. For that, the theorem is basic one is basic proportionality theorem, very famous. It is known in BPT form, short form, BPT, basic proportionality theorem. First we go for the statement. If a line is drawn, the line is drawn parallel to one side of a triangle, intersecting the other two sides AB and AC in two distinct points X and Y, other sides in two distinct points. We can change the points also to any other point, X and Y. Then the other two sides are divided in the same ratio. By it means what? The line drawn is parallel to one side. The line is drawn parallel to one side of a triangle, intersecting the other two sides in two distinct points, such that the points are between this A and B and A and C, such that the line divides the other sides into distinct points. Now, then the line divides the other sides like AB and AC in the same ratio by the line drawn. That is, what is the proof we have to make? AX upon XB is equal to AY upon YC. This is what you have to prove. Given condition, line is parallel to BC. Then what you have to prove? AX upon XB equal to AY upon YC. Agreed? Now we have to construct. Construction is there. Join Y, this BY. Now you have to see two triangles. The small triangle AXY. Triangle AXY. Proof. In triangle AXY and triangle BXY, AXY and BXY. What is saying? Area of triangle AXB, AXY upon area triangle BXY equal to AX upon XB. See, these are the bases. Height is from here, From here we draw perpendicular like this. In triangle AXY, if AX is the base, if this is base, height is from here like this. From the third vertex, AX2 vertices of the triangle AXY. Third vertex is Y. From here Y, perpendicular drawn. That is the height. For this triangle BXY also, BX is the base. So height is from third vertex perpendicular to the same side. Same height only, no? So here we can say triangles with same height. Triangles with equal heights. Actually one of the same height only. Okay. This is first statement. Now second statement. Now what we are considering? from this side, from the opposite side we consider in triangle AXY and triangle. Now we have to go for the joining this part CX. So in triangle AXY and here it is CXY. CXY. Here also area triangle AXY upon area triangle CXY equal to. Now bases are from this side. Now we have to consider from this side. Earlier we tried from this side. First we tried from this side. Now we are trying from this side. Bases are this AX and YC. Sorry, AY and YC. AY, YC, this base. So triangle AXY is base is AY means height is from X, like this. Like this perpendicular. Like this perpendicular. If this triangle CXY is the triangle, base is CY. From this side, base is CY. So height is from third vertex, again the same thing. Here also triangle is the same height. AY upon YC. What is reason? Same reason. Triangles with equal heights. Now we have to recognize another thing. See the base of denominator of both first and second. Numerator one and the same. See area of triangle AXY. Here also the same thing. A triangle, area of triangle BXY. BXY and this one CXY. But area triangle BXY is exactly equal to area of triangle CXY. Why? What is reason? Triangle BXY and also CXY, same base is XY we can consider. For the triangles BXY and CXY has the base XY. Height is what? Height is between two parallel lines. BC containing line parallel to this line. So height is like this, here like this. Perpendicular we can consider. The heights between two parallel lines, the perpendicular distance is a fixed quantity. Perpendicular distance between two parallel lines is a fixed quantity. Therefore what happens? The triangles BXY, base is XY, height is perpendicular height. And the triangle CXY, same base XY, height is perpendicular. Meaning the same base and the equal heights. So triangles with same base and height. Therefore what happens? Bases are equal. See the denominator of first one, area of triangle BXY. This denominator you see area of triangle CXY. Both are equal. Meaning denominators are equal. Numerators are also otherwise also equal. Therefore what you are getting? Area of triangle this AXY upon area of triangle this BXY is equal to this one. Area triangle AXY upon area triangle CXY. Why it is so? From 1 to 3. From first statement, second and third statement. Therefore, the first, its left hand side is what? This ax upon x. Therefore, ax upon xb equal to this. This quantity is here ay upon yc. This is BPT. Means what? Ax upon this distance ax upon xb is equal to ay upon yc. Provided the line is parallel. Given BPT, given line is drawn parallel to one side of a triangle, intersecting the other two sides in two distinct points, then the other two sides are divided in the same ratio by it. It means the line drawn. The line drawn parallel to one side, intersecting other two sides in two distinct points, then x upon xb, the ratio is equal to the other ratio ay upon yc. If ax upon xb equal to ay upon yc, then the line is parallel. Converse statement is what? If the ratio ax upon xb equal to ay upon yc, line is parallel. What is BPT? BPT says if line is parallel, then ax upon xb equal to ay upon yc. BPT is what? Line is parallel. Then what is that statement? We are reaching it. Proof is ax upon xb equal to ay upon yc. That is the proof. In converse of BPT, it will be given that ax upon xb equal to ay upon yc. This will be given. In converse, this statement where we reached in BPT, result will be given. Where we have to reach, the line is parallel. Line is parallel. In BPT, line is parallel, then ax upon xb equal to ay upon yc. In converse, if ax upon xb equal to ay upon yc, then the line is parallel. Okay? This is BPT's first part. Basic proportionality theorem plus converse. Now its applications we have. That is angle bisector theorem, then converse of that, and also one more extension of that, intercepts made by three parallel lines. Today we just have the introduction of that. Tomorrow we do that in detail so that you can clearly understand. I will explain here. Suppose a triangle we take here. Suppose this is triangle ABC. Now what we do here? There is an angle bisector. Suppose this S. AS is bisecting the angle BAC. Means these two parts are equal. Ray AS bisects angle BAC. Then what we have to prove? AB upon AC equal to BS upon CS. BS upon SC. What is saying? What is this? Angle, property of angle bisector. Property of angle bisector. You people don't worry, all this we do in detail in the board. Now this is only the difficult time to get over. The difficult time is only for the time being, hardly for a few more days. After that, we will do in detail in the board. It will be very clear to you. But at the same time, you can study all these points. Therefore, we are making it. In triangle ABC, AS is a bisector of angle this A. That is angle BAC's. These two angles are equal. This is bisector. Therefore, what is that? This means this AB upon AC is equal to BS upon CS. Actually, how we are going to prove tomorrow, I'll show you. Extend this BA, extend the BA and draw a line parallel to through C parallel to SA. Means like this. What happens here? We consider BA produced to say A, B, C, S, so here we can make A, B, C, D, another point D. So we have to prove now these triangles are, this triangle ACD is an isosceles triangle. How we make it? See, SA parallel to CD. How we got it? This is by construction. If we construct CD parallel to SA, CD parallel to SA. So what is this? This is one pair of alternate angles. 9th standard you studied. Two lines are parallel. It's a transversal. So this is one pair of alternate angles formed. Alternate angles formed are congruent because the lines are parallel. These two lines are parallel. Also, this BAD, BD is a transversal. For this the same two parallel lines. Therefore, what is this? This is one pair of corresponding angles. Corresponding angles are congruent if lines are parallel. So we do today itself that proof. Here, construction. Construction. What? Draw line CD. Parallel to SA. This line is parallel. AC is a transversal. Segment AC is a transversal. Therefore, what happens? Angle SAC is congruent to angle ASD. Sorry, ACD. What is the reason? Alternate angles. Alternate angles. Second one is what? Angle these two are congruent. BAS. Angle BAS is congruent to angle ADC. What is the reason? Corresponding angles. Corresponding angles are congruent. But this is what you have to prove. I put in a box. But these two angles are congruent. See here. This angle congruent to this. This angle congruent to this. But these two angles are congruent. Their corresponding congruent angles are also congruent. But angle BAS congruent to angle SAC. What is the reason? Since ray AS bisects angle BAC, or you can directly say given. Now see what happens. We said these two angles are congruent, corresponding congruents, these angles are congruent. Therefore, angle ACD is congruent to angle ADC. If at all we give this is 1 and this is 2 and here this is 3, from 1 to 3, from 1, 2 and 3, we are getting this. If these two angles are congruent, triangle ACD is an isosceles triangle. Therefore, triangle ACD is an isosceles triangle. Isosceles triangle. Therefore, what happens? Therefore, AC is equal to AD. Therefore, AC is equal to AD. This we require. Now we use BPT because we are doing BPT only, no? Now, in triangle BDC, see the whole big triangle BDC. What happens? This line is parallel. This line is parallel to this side, you know. In triangle BDC, ACE is parallel to side CD. Therefore, what happens? Therefore, BA upon AD. Start from this vertex. Big triangle we consider. BA upon AD is equal to, see, from here we start, you know, BA upon AD equal to BS upon SC. BS upon SC. Therefore, BA is same as AB. Now, AD becomes what? AD becomes what? AC, that you put here. This is AC now. This part BS upon SC. This is what you are getting. Theorem. What is the reason? Since AD equal to AC. This is what you have to prove. See, this is property of angle bisector. Property of angle bisector. What is property of angle bisector? If an angle is bisected, then ratio of the sides of that angle is equal to ratio of their corresponding opposite sides, or simply corresponding sides, meaning AB upon AC equal to BS upon SC. See, the side AB upon AC, numerator ends at B. AB upon AC, numerator ends at B. Therefore, start from there. Second ratio is BS upon SC. This side's corresponding side here, this side's corresponding sides here. That is AB upon AC equal to BS upon SC. This is property of angle bisector. It's application of BPT only. See, in triangle BDC, this line is parallel to this side. Therefore, BA upon AD equal to BS upon SC. That is the application of BPT to prove property of angle bisector. Agreed? All of you please practice. Do practice. You will get enough confidence. Still more doubts are there, you can ask me and we will clear it. Okay, this one.